This is Camera TrafficWatch. And what is Camera TrafficWatch, you might ask yourself, and what have we used it for in the project? So Camera TrafficWatch is a cloud software product that we have deployed in this project inside of Volvo Cars Cloud. So when you're working with clouds, you can either do a cloud-to-cloud communication, or you can just deploy it right in the cloud that you're actually using. And when you do that, obviously, Volvo in this case has control of all the data flows going in and going out. So it's very secure in that way. And that's why we decided to set it up this way in the project. And it also allows us to read all kinds of different data from Volvo Cars in this case, and also combine it with other third-party data. So you might be wondering, well, where is all the data? And I'll show it to you just in a second. Just want to mention as well that Camera TrafficWatch is a back-end product, and that's the focus of what's happening in the back-end and providing safety and providing situational awareness to connected or automated fleets. But we also have this UI for demo purposes to sort of explain to you what's happening in the back-end and behind the scenes. So what you see here, obviously, is a map of Gothenburg and a map of Sweden, or a map of the entire world, actually, if we zoom out far enough. And as you can see right to the left here, there are some vehicles. You can't see them in the map quite yet, but don't worry, you will really soon. And we also have what we call situational awareness. So this is where we read data from third parties. Obviously, in this case, in this project, we have HERE, like we just talked about, HERE Technologies. We have a company called NIDA providing us with friction data on the roads. And we also have data straight from SOS Alarm, which is Swedish emergency vehicles. And then in this project, we combine it with alerts from the actual Volvo Cars fleet. So we have the hazard light situations, which is when a vehicle flashes its hazard lights. We also have slippery road alerts. So this is also friction data, but directly from the Volvo Cars fleet. And then, of course, the main attraction, like Hampus talked about, and Carl as well, the accident risk situations. So let's actually turn on some of this data so that we can view it. And I'll go from the top with the HERE data. So you can see these yellow things in the map. That is situations that HERE has reported. And of course, Camera TrafficWatch is a data agnostic product. So what that means is that we read data from third parties or first parties, in this case, Volvo Cars, and we sort of translate it to our Camera TrafficWatch language. And in that language, we call these things that happen on the road situations. So when I mention the road situations, it's basically something that has happened on a road. We can go ahead and click on one of these situations to figure out what it is. So you can see right here, there are some lane constructions going on at Lantbruksgatan in Gothenburg. There's also some constructions, and there are some lanes closed as well. And from here, we read all kinds of data. So we have these kinds of lane restrictions, congestions. It might be accident data. Really any kind of data that the HERE platform provides. We read it and we use it in this project. So that is HERE, and we're going to continue going down the list here. So we're going to turn on the layer for NIDA slippery road situations. So that are those white things that you can see right here. And if I click one of them, you can see that we have the exact friction data that has been measured by Naira Dynamics. So that's just another layer that we combine into this product. And we're going to continue going down the list, and we're going to turn on some live emergency vehicle positions. So if we zoom out to all of Sweden here, these are all the Prio 1 emergency vehicle missions going on right now. You can see them blinking whenever they get an update. And what we do with this data in Camera TrafficWatch, and which we have developed in another project called Nordic Way, you might have heard of it, is we know where the vehicles are, and we know roughly where they're going, not exactly because that's sensitive, but we have a good idea of where they're going. So if we zoom into one of those here, we can see that this is an ambulance, and we can also see that there is a sort of a line right here. And as you can also see, the vehicle is jumping a little bit. And that is because from SOS Alarm, we get an update on the vehicles every 30 seconds. So in between these updates, we actually simulate what we think will happen in those 30 seconds based on the speed of the vehicle whenever we get these updates, and of course also the heading. But this thing that you see in front of it, that's the important thing, because that is also a camera to traffic watch situation. So that is another stretch of road where basically TrafficWatch knows that something is going on, and it might be something that you want to warn vehicles for. And we'll get to that later, of course. Yeah, so those are the third parties that we have used in these projects. And if we continue going down here, we can see that we have some hazard light alert situations, and we're going to turn those on as well. Now, luckily, some people were flashing their hazard lights in Sweden right now. Obviously, never know if that's going to happen. But obviously, if a lot of vehicles are flashing their hazard lights in the same place, you might also think that something is happening there, even if it hasn't been reported by any of the other third parties or anything else. This is also a good indication of that you might want to take it a bit slower. Yeah, so we'll keep going down the list. And now we get to the slippery alert situations. And that's basically a Volvo vehicle that has measured its friction and realized that the value is quite low. And as we go into the winter months, you can see there are a lot of these in Sweden. And of course, we've talked about California, and we'll get to that later. Don't worry about it. Reason we're showing Sweden first, because there's a lot more slippery roads in Sweden right now than there is in California. But you'll see that later. Yeah, so these are all the slippery road situations that have been reported by Volvo cars, and they have been brought into the system as a situation, just like anything else. And then we get to the last layer here, which is a red layer. And red obviously signifies some danger. And these are the accident risk situations that Carl and Hampus talked about before. So as you can see, we've combined all of these into one system here. But then you might ask, what do you do with it? And that's when we get to the vehicles. So the layer I just turned on, and as you can see, there's a big red blob here. These are Volvo Cars vehicle positions that are read directly inside of the Volvo Cars cloud and then sent to this UI. And if we zoom in to Gothenburg here, we can see that when we zoom in, they turn from a heat map to the actual individual vehicles. And it's not really rush hour yet, but we're getting close to it. And there's a lot of vehicles moving around in the Gothenburg area. Now, you might wonder exactly what these vehicles are. And like we said, it is Volvo Cars vehicles. And it's from people who have consented to sharing their position. Of course, there's the GDPR and the safety thing here. But with a new Volvo vehicle, you can decide whether you want to share your location or not. And as in return, you sort of get access to these slippery road alerts and other things that might be developed by Volvo thanks to your sharing of your location. So that's all the vehicles that you see here. Obviously, there are more Volvo vehicles. Some of them have elected to not share their positions. And another thing that you might mention or notice right away is that some vehicles are green and some vehicles are yellow. And this is where we'll get into the safe speed concept and the safe speed part of the project. So if I just go ahead and click on one of these green vehicles in the middle of the screen, you can see we start following this vehicle around in this little map over here. And you can also see this UI in the middle. This vehicle is standing still right now, so it's 0 kilometers per hour. But you can see one interesting thing at the top there, which is the 80 status enabled. So what that means is basically that Camera TrafficWatch has not noticed anything going on this stretch of road that the vehicle is on right now. So from all these third parties that we saw before and for the first parties and from SOS Alarm, none of these are happening right now at the location of this vehicle. And as such, the safe speed of the vehicle obviously will be the speed limit of that road, which is 50 kilometers an hour, as you can see right here. And you can also see that no situation has been detected by Camera TrafficWatch. And on this side here, you can also see 98% state of charge. That is the only value, that is actually simulated. So we don't have the state of charge from the vehicles yet, but we have all the infrastructure behind it to get all this information into the system. But I just wanted to point that out, that that value is simulated. All the other data that you see here is real time and also real. But yeah, so this is a vehicle that has a safe speed that is just the speed limit, but that's not what we came for, right? So let's go ahead and click one of these yellow vehicles right here. Now, as you can see, the AD status for this one is disabled. We do not recommend driving autonomously right here because something has happened on this stretch of road. And as you can see, the speed limit here is 70. That's the regular, normal speed limit that we all know and love, I was going to say. I don't know about that, but we all know it. And then there is the safe speed right below it. And as you can see, in this case, it's lower, 63 kilometers an hour instead. And the reason for this is also right below, because this vehicle is on a construction that has been reported by HERE Technologies. Now, of course, this is just a small lowering of that, that speed limit. But if this vehicle were to be on an accident risk, for example, we would lower that speed limit even more. And how much we're lowering it, that's sort of still to be decided. But we do have all the data to be able to do this and have a speed limits that it's actually dynamic depending on the situations and what's going on around your vehicle. So that is the safe speed part of the project. And every time we get a new position from Volvo Cars, we actually map it towards everything that has happened or is happening right now in real time in the system. And we basically figure out if it's on one of these situations or not. And as I mentioned before as well, these situations can also be the predicted route of an emergency vehicle, which is obviously a short-lived situation, but is also very important. And you can send different directions to the vehicle depending on the different types of situations. And it's also, of course, very possible that you are on multiple situations at once. There might be an accident risk alert where there is also some construction or some slippery roads. And of course, then you would want to drive even slower. And we're keeping track of all of that in TrafficWatch as well. And another thing that is great to look at when you have all of this data together like this is, you know, we had slippery road alerts from the Volvo Cars fleet. And we also have friction data from NIRA. So you might look at that data and sort of compare it to each other and see whether Volvo and NIRA in this case agrees. And of course, if they do, then that lends a lot of credibility to that actual friction value on that road. So of course, the more data we have and the more we can sort of put it together, the more certain we can be about the safe speed concept. So yeah, that's the safe speed. And I'm going to go ahead and move over. Before we go to the US part, I'm going to go ahead and talk about the energy use case. So if we zoom into Gothenburg here again, let's see. I think my computer is a bit mad at me for sharing my screen and doing things at the same time. But it's going to have to bear with me. So we can turn on another layer here, which is charging stations. So these are all the charging stations around the Gothenburg area. We can click on them and we see the number of ports and basically the available power at this charging stations. And this is great, but alone, it's not really helping all that much. So what we have done is actually to create a heat map for the energy demand of a fleet and also the energy supply of a fleet. So I'm just going to turn those on right now. We're going to start with the energy fleet demand. So what you see here is a bunch of red dots in the UI. And basically, the lower state of charge that you have, the bigger your dot will be in the UI. So if you have a really big dot, that means that you have a really low state of charge and you're in need of energy to your vehicle. And if you have a small dot, then you'll be in need soon. And if you're not on this heat map, then you're fine, basically. So of course, we also need the other part of that equation, which is the fleet energy supply heat map. So you can see right here is a good example. Here, there's a big red dot, and there's also a big blue dot. So this vehicle does have a lot of state of charge, and this vehicle right here has a lot of need for more state of charge. And of course, you can see that over the entirety of Sweden here right now, because we're reading vehicle positions from all of the vehicles in Sweden in this UI. And you might have heard that vehicles in the future will be able to charge via other vehicles. So a vehicle that has a 90% of state of charge will be able to charge a vehicle that has a 10% of state of charge. And that's great for you and your friend. And you can sort of help each other out, but it's very valuable when you have the entire fleet. And if you can view the information really, really easily, you might know that in a certain part of the city, there's a lot of demand right now. And in other part of the city, there's a lot of supply. And also, if you combine that, of course, with the charging stations, which is in itself a supply, then you can come to some interesting conclusions right there. Of course, there's way more to do in this part, but this is a good start to basically just know how does the situation look in my fleet at the moment. So yeah, I think those are the things that I wanted to show in the UI right now. And I also promised you, of course, that we're gonna jump over to the US. So let's do that right now. So in the US, you can see there are a lot of Volvo vehicles right there, and there's a lot of people who are willing to share their location there as well. And something that is really interesting to see when you look at this UI is that you can really see sort of the US waking up. And as you can see, the line is somewhere around Kansas City right now, where people have woken up. And of course, as the evening goes by here or the day goes by there, it sort of grows over to California. So of course, we have focused on California in this project. If we zoom into California right now, we can see that there are not a lot of vehicles right there. And of course, that also means that there are not a lot of slippery road alerts or accident risk alerts necessarily right now, right here, because, well, there are no people driving. But in other parts of the US, people have woken up. And this is the reason why I wanted to demonstrate the Swedish UI first, of course, because there's a lot more data there right now. But as you can see, there's also the emergency vehicles inside of the US. And there's a lot of them. So there's actually fire trucks, ambulances, and what they call emergency response vehicles. And basically all kinds of emergency vehicles in the US as well. As you can see, there are a lot more where there are people awake, but even in these parts, there are things happening in the middle of the night. So yeah, I think that's the UI of the US, and that's the UI of Sweden and Gothenburg. And as you can see in the previous projects, we've always focused on sort of smaller areas. But in this project, we went to all of Sweden in that one UI, and then all of US in this other UI. And this is actually two separate instances of Incremental TrafficWatch running inside of the Volvo Cars cloud. One in sort of the American environment, and one inside of the Swedish environment. And we're doing all the same things in the US as we're doing in Sweden. So if there were more vehicles over here, you can see that they are green or orange as well, if they are map matched to a situation. But like I said, they are sleeping. So that's why you saw it in Sweden instead. Thank you for listening. And that's all for the demo.